Hello, ladies and gentlemen, and welcome back. Root Beer here with question number 19 on our 2011 Fermat paper. In the diagram, the two circles are centered at O. Point S is on the larger circle. Point Q is on the intersection of OS and the smaller circle, and then it looks like we got a nice little right angle here. Line segment PR is a chord of the larger circle that touches, that is to say tangent to, the smaller circle at Q. So it just comes in, just touches right there at Q, and then continues on. Note that OS is perpendicular to, is the perpendicular bisector of PR. This is general circle results. You take any circle and you take a chord, the line from the center, the radius from the center that passes through the midpoint automatically is a right angle. This is a nice little circle geometry result. But they're giving that to us for free. All right, if PR is 12 and QS is 4, then the radius of the larger circle is... Well, let's get a copy of this picture. I want to draw it a little bigger, so I think we're going to get a fresh sheet of paper. That was a very nice, very nicely done tangent. I do say so myself. All right, so we know we've got 4 here, S, Q. Now, PR is 12. Oops, I'm already jumping ahead in my head. PR is 12, and so if it's been divided in 2, we get each of these are 6. Now, what are we trying to find? Well, we're trying to find the big radius, the radius of the large circle. We could call that little r. Normally, I'd call it capital R, but we've already got a point with that name. And so, well, where could we see that? Well, here's a radius. OS must be R. Now we've already got 4 here, so that must mean this is R minus 4. OQ is R minus 4. But we have another radius if we connect up OP. Same if we connected up OR, but we only need one of them. And remember, they said we've got a nice little perpendicular bisector, so we know these are all nice little right angles here. So we've got really a nice little right angle triangle, and we know some of the sides. We know some things about some of the other sides as well. So what have we got? Well, r squared must be 6 squared plus r minus 4 squared. Just Pythagorean relationship. So r squared is 36 plus r squared minus 2 times 4 is 8r plus 16. And so the r squareds will cancel out. We can bring the 8r over onto this side. 36 plus 6 would be 42 plus another 10 would be 52. 52 doesn't divide through by 8. It does divide through by 4. 52 cards in a deck, so divide by 4, you get 13 cards in each suit. So R must be 13 over 2. Now, I'm a little hesitant to that. I would expect to have a nice integer solution, but let's look at the possibilities that they present for us. No, 6.5, and you'll notice everything else is written in decimal. If I was to expect a nice little integer solution, I probably wouldn't be seeing these decimals. And 6.5 is 13 over 2. So I'm really confident in my answer now, seeing these. And so we'll say it's C. If I wanted to be even more confident, what I could do is I could say, well, what is R minus 4? Well, that would be 5 over 2. This one here would be 12 over 2. And we're saying this is 13 over 2. And now I'm really confident because I recognize 5, 12, and 13 as being from a Pythagorean triple. Okay. So there we go. That's it for question number 19. Up next will be question number 20, and I will see you for that in just a moment.